Hello friends, today we are going to see a rigid body rotator. This rigid body rotator is a free rigid body rotator. Again, then first we see what is the rigid body, and for that consider a system having two particles. So there is a two particle system, one is M1 and another is M2. These two masses M1 and M2 are attached, joined by a light rod to each other, and there is one point in between these two, M1 and M2 is a center of mass. Say this is a center of mass of this system, and the whole system is rotated about this axis which is passing through the center of mass. So this total. So this M1 is rotated along this path, and this M2 is rotated around this, and therefore R1 is a distance, a radius of rotation about the center of mass, and R2 is for that of the second mass, and one more is R is the distance between two particles. R is a distance between two particles. Okay, in this situation we are going to see what is the moment of inertia of one single particle. Say moment of inertia when this M1 is rotated, so this is the M1 point. M1 is rotated around this axis of rotation point. Then what is the moment of inertia? So this moment of inertia for the M1 particle is a product of mass into square of distance from the axis of rotation. So this M1 R1 square, M1 into square of distance from the axis of rotation, and that is square. So this is nothing but the moment of inertia of the particle 1. What is the for the second moment of inertia for the second particle is M2 I2 is equal to mass, product of mass and the square of distance from the axis of rotation, and therefore this is the M2 R2 square. Okay, and this system contains the two particles. So therefore the total moment of inertia of the total system is nothing but I is equal to M1 R1 square plus M2 R2 square. I is M1 R1 square plus M2 R2 square. This is the moment of inertia of the system, two particle system. Okay, we know that this R is equal to R1 plus R2, and therefore one more relation we know, R is equal to R1 plus R2. Okay, now there is a challenge to us how to convert the two particle system into one single particle system, and then we find out what is the energy of that one. Okay, and that is called conversion of the two body system, or any particle more than particle system contains the more than particle, so that is reduced into the single particle, and that is called the single particle system. Okay, so we will do that one, and for that now consider this R1. So this is the center of mass. What is the concept of the center of mass? You know, see the center of mass, say this is the coin, and this is your the ground square. When this coin is rotating along this, so it is go on rotating. Okay, so this is the center, and consider the all points, and see there. So these are the all points, and when it is the gone rotating, consider this point. So this point will be rotated like this, one single point. Okay, so there is one point inside the coin which travels in straight line, or all other points are in circular motion, and therefore, and that is the center. So this center point is one point which is only travel in straight line. That means that is called the center of mass. So the center of mass is the point at which we supposed to be whole mass is supposed to be concentrated at one single point. So that is the concept of the center of mass. So this around the center of mass, the mass is equally distributed. Suppose this is pan, and suppose this is the center of mass. So now these two branches are the balanced at this one. So this is because of what? Because of this portion, mass distribution of the mass on left side and distribution of the mass on right side is equally distributed, and therefore around this point center of mass, and therefore it is balanced. Okay, here also this mass is distributed about this center of mass, and hence therefore it is called as the m1 r1 is equal to m2 r2. m1 r1 is equal to m2 r2. From this equation you find out for the value of the r1. So this r1 is equal to m2 divided by m1 into r2. So this, okay, put this value of r1 is here. So we can consider this one, this 2. Put this value of r1 here. And what happens there? So r is equal to m2 r1 into r2 plus r. Put this value of r1 in the equation 2. We have r is equal to m2 divided by m1 r2 plus r2. You take the r2 common here, and therefore this becomes m2 divided by m1 plus 1 is equal to this r2 into bracket m1 plus m2 divided by m1 is equal to r. Okay, so m1 r is equal to this m1 plus m2 divided by m1 into r2, and therefore from this value of the r2 is what? And therefore value of the r2 is equal to, you transfer here, so this is m1 divided by m1 plus m2 into r. Okay, so this is equation 3. Now value for r1 is equal to m2 divided by m1 plus m2 into r. So now these are the two equations are in terms of r. So r1 is in terms of r and r2 is in terms of the r. So we are converting r1 and r2 in terms of the r. Okay. Now put this value of the r1 and r2 from equation in equation 1, and equation 1 is what? Equation 1 is m1 r1 square plus m2 r2 square. Put this r1 is equal to here, so square of that, then m2 divided by m1 plus m2, and is equal to we get this m1 into bracket r1 square. So this is the m2 divided by m1 plus m2 square r square plus m2 r2 square, and value of the r2 is what? Value of the r2 is m1 divided by m1 plus m2 square of that, and this is the r square. So r is equal to, and then moment of inertia for that is m1 m2 divided by m1 plus m2 r square. Okay, so this m1 m2 divided by m1 plus m2 is called the reduced mass, and that is the mu is equal to I is equal to mu r square. Okay, here we are converting this two body problem into the single body problem. Here the mu is the reduced mass, means the whole mass is the body of the considered to be a concentrated at one single point, and that mass is defined as m1 m2 divided by m1 plus m2, the product of the two masses divided by a sum of them. There are the 2 points in therefore in general formula. So for the general formula, this a product of the all masses divided by a sum of the all masses, sum of the all, and therefore this is called the reduced mass. Okay, so this is the moment of inertia. Now what is the energy, kinetic energy for that? So kinetic energy for this system is equal to 1/2 I omega square. Ke of this system is equal to 1/2 I omega square. Okay, I am purposefully writing this I square omega square, therefore this is the I. And one more formula, we know that L angular momentum is equal to I omega, and therefore L is equal to I omega. I square omega square is nothing but the L square, and therefore the kinetic energy is equal to 1/2 L square by I is equal to L square divided by 2I is nothing but its energy, kinetic energy of the a particle, a rigid rotating particle. Okay, now this omega, the value of the omega is changing from a 0 to infinite. If the omega is gone changing, mass m1 and m2, these are the constant, therefore the mu is constant, moment of inertia of the body is constant, and therefore this E has a continuous spectrum, and therefore in a rigid body problem, rigid body rotator problem, the energy is a continuous spectrum. So this is a classical picture.